Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside, you may be continuing from my last video entry on trigonometry finding missing sides. This is trigonometry finding missing angles. So using all of SOHCAHTOA, sine, cosine, and tangent, this works in tandem with your 9.4, 9.5 material in the Big Ideas Math, Integrated Math 2 textbook. If you follow along with that stuff, you can find those videos as well somewhere on my channel or in a certain playlist or what have you. But this combines sine, cosine, and tangent together, but this is about finding the missing angles using inverse trigonometry. So get your calculator ready, download this PDF below, this worksheet of, let me see how many problems here, I didn't even check it out, of 12 problems on the front and 4 word problems on the back side, and we'll go ahead and go straight to it. Now, I am assuming that you've seen this kind of material before, at least in such a way. I want to be able to solve these things, that's all. All right, we're going to find each angle measure to the nearest degree. Now, they say on number 1, the sine of v equals 0.9455. Remember, this is a ratio of something, right? It's opposite over hypotenuse, and this is the value you get. When I hit a button, sine of something on my calculator, and I get 0.9455 out, what was the angle that we had? And that's what this is all about. So I'm going to write that one more time, just to give you the idea of what we're actually going to be doing here. I want to give some space with that. How do I get v by itself? You take the inverse sine of both sides. It looks like this. You take the inverse sine of this side. You take the inverse sine of that side. The inverse sine of the sine of an angle is just the angle. V equals, and the inverse sine of 0.9455, what happens when you take the inverse sine of a ratio? You get an angle out from it. So if I go to my calculator, and oh, this is still my stuff I had from the last trig finding missing sides. I literally just started a new video. Inverse sine is above sine, not the apps button, but that icon right there, which means I still got to hit this button, but I got to hit second first. Take the inverse sine of, and I'll do 0.9455. Now, you want to make sure you're in degrees before I keep moving forward. Make sure you're in degrees, otherwise you'll get a radian measure, which means nothing to you. This answer will be a degree value. 70.996, V is about, they said to the nearest degrees. That's 71 degrees to the nearest one. So that's what we're getting here, 71 degrees. That answer I just put right there, that is D. Now all these problems work like that. It's all about inverse items. See, we don't just hit sine. See, what happens if I hit sine of 0.9455? Not just what's the answer, what does it mean? First of all, that's the answer. What does that mean? That means you've just treated 0.9455 as an angle measure, basically like 1. It's like the sine of 1 degree. And in the sine of 1 degree, what you essentially did in that situation is you found the opposite. Here's a 1 degree. You found the opposite over hypotenuse, how these things divide. And they divide so small that you get some 0.01 value, and that's not what we're doing. But let's keep moving forward here. Number 2, cosine of z is 0.3090. Well, now z, that angle measure, is going to be inverse cosine of 0.3090. So that's how you get your variable by itself. You don't divide by cosine or anything like that. That actually doesn't make any sense whatsoever. But we now do cosine of 0.309. I don't even need the 0 after that. We get 72. See, if I hit cosine of 72, I mean, I know this is me rounding when I say 72. When I hit cosine of 72, here's what I get as an answer. 0.3090169944. 72 is the angle you take the cosine of to get that ratio. Right? That's what we're doing. And I said I won't be teaching, but I am. Z is about 72 degrees. I think sometimes with multiple choice, I could probably look at it best and tell you which one it is. I know it wouldn't be B or C. I don't know if it would have been D. This one's too hard to tell between C and D. All right, number 3 and 4. More of the same. That being said, no multiple choice, so I have to do this all on my own. W is the inverse tangent. Take the inverse tangent of both sides of 0.6745. That's the exact answer. Always please write exact answers in your things before you go to the approximation. And we're going to round to the nearest degree. It looks like each time they seem to be setting us up in a way that's close enough to that degree we're looking for. 0.6745, like that one. That looks like 34 degrees were intended. And that's going to be that one. Here on out, unless I want to show something in particular, I'm probably not going to show you my calculator, so just go ahead and be ready for that. Cosine of v is 0.9703. This time v is going to be the inverse cosine of 0.9703. If you were to predict certain answers of these types, it should be a smaller angle this time, because that ratio adjacent over hypotenuse means the adjacent and hypotenuse are pretty close in length, which means the opposite side probably ain't that close in length, which means it's probably a small angle we're talking about. All right, inverse cosine of 0.9703. I'm trying it here. I get 13.99, so around 14 degrees. Again, that was what was intended. All right, I don't know why. Oh, I don't know why I didn't switch over. I also don't know why number 2 is in green while the others are in blue. I'm mostly using blue here, all right? All right, let's move on to number 5. Find the measure of the indicated angle to the nearest degree. Now, this time, and by the way, I'm going to probably be using X's in these places of these question marks. Hope that's all right. You could totally use whatever. Actually, let's use theta. Let's use theta. Theta is a Greek. It's this symbol I'm doing right here. It's a Greek letter. So I'm going to use theta in place of the question mark for all those ones as I keep moving forward. So with this one, let's set it up as we generally would. And I know you can probably do this without that, but I'm going to always set this up the right way. Saying the tangent of this angle, this unknown angle, has a ratio of 26 over 23. Now, why did I choose tangent? In SOHCAHTOA, opposite and adjacent uses the trig function tangent. There's my setup. Now, I want to find the angle measure theta. This is where you take the inverse tangent of both sides. Now, I don't always write it that way, but I'm going to, at least for that first problem, to remind you, that that's what we're doing. So theta equals the inverse tangent of 26 over 23. And it'll be some angle measure. I know it'll be slightly more than 45. I don't know how much more. Let's just take a look at that one. Inverse tangent of 26 over 23. And don't round 26 over 23. Please make sure it's exact. 48 point, they said nearest degree. 49. Around 49 degrees. And that's an option. On here, it is option A. Number 6. Theta's right here. I have my adjacent as 3, my hypotenuse as 10. Automatically, I'm already thinking like, hey, I want to write the answer straight up. Nope, we'll still work on this. Cosine of our angle is 3 over 10, which is also 0.3, which you could, right? I don't want to make a mistake in a calculation, though, so you probably don't want to do that. So theta is the inverse cosine of 3/10. Let's figure out what that angle is. Inverse cosine, I won't show you the calculator here. 3/10. 72.54, so around 73 degrees. And that is answer B. It's about that many. That's B. Let's keep moving forward. More of the same. Number 7. Also a cosine problem. Cosine of your angle here is 18 over 30, which can reduce as a fraction. But once again, you probably want to avoid the fraction reduction stuff. There's nothing wrong with fraction reducing. It's just it takes more thought and you might mess up. But if I did inverse cosine of 18 over 30, or inverse cosine of 3/5, or inverse cosine of 0.6, the answer is the same. You just got to make sure you get those values when you simplify them. So it all depends on what you have. Inverse cosine of 18 over 30 is about 53 degrees, is what I'm getting. Number 8, also cosine. Gee, I didn't really think this worksheet through when I made it. Go figure. Also a cosine problem. Hopefully we're going to run out of some cosines where I can pick and choose what I want to do. You know what? This time I'm going to go straight to it, right? Theta is going to be the inverse cosine. I'm still going to write the exact of 40 over 51. Just straight up set up adjacent over hypotenuse. We've seen the last few problems do that. So let's go ahead and write that one out. Inverse cosine of 40 over 51. Can't reduce, and I don't care. 38 degrees is the thereabouts. Okay, that's the first 4 in that section. Let's go to the last 4 in this section. Now, these ones here, it's funny when you have more options that people freak out more and go, whoa, what do I do? You look at this one, you might say, I know what to do. And then suddenly you get all 3 sets of sides. You're like, I don't know what I don't know what to do. Here's the thing. You got 3 options. You have the sine of, let's still call that theta. The sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse, and the tangent of theta is opposite over adjacent. What does this mean? To get theta by itself in any of these three situations, you got to take the inverse sine of both sides here, inverse cosine of both sides here, or inverse tangent of both sides here, as if to say that theta equals the inverse sine of 68 over 85, but it also equals the inverse cosine of 51 over 85, and it also equals the inverse tangent of 68 over 51. Any of these three will give you the exact same value as long as your calculator's in degrees and you type it correctly. Let me show you. Inverse sine of 68, I don't know what the answer is, but 68 over 85 is this number. Inverse, oh, look, we saw this number before. Maybe those could have reduced and I wasn't really looking. Inverse cosine of 51 over 85 is, well, you know what? It's that number. And the inverse tangent of 68 over 51 is the same number. No matter what you do, you're still going to get that number of 53 degrees, which, like I said, was an answer on number 7 or something like that. So 53 degrees, that answer is C. Awesome. We get to move forward. Number 10. Sorry that this kind of gets in the way. Let's move it. There we go. So you can choose sine, cosine, or tangent. What haven't I done most recently here? We did a bunch of cosine. Tangent. We haven't done sine in a while. So let's do a sine problem here. I'll do tangent on another. Then I'll revisit cosine one more time before we hit the others. So sine of that unknown angle there is 32 over 40. To humor you, although we're not going to be able to do, I'm not going to write both. Theta is the inverse sine of 0.8. Mr. Robinson, why did you say 0.8? I thought it was 32 over 40. Well, 32 over 40 is 0.8. So I can go ahead and still type that in. I don't know, I'm showing you. Inverse sine of 0.8, but you're still getting a value out of that. It's 53 degrees again? Aren't they sick of that answer? It's the exact, it's literally, these are literally similar triangles. I'm literally, I didn't know that. I didn't know that these are 3, 4, 5 triangles. I didn't know that either. So, unbeknownst to myself, I don't know how, we keep getting 53 degrees, which is just amazing. All right, number 11 does not look like it's one of those problems. 12 might be. I would just have no idea. 12 might be a 3, 4, 5 triangle. 18. 12 is a 3, 4, 5 triangle. It might not be the 53 degree angle measure, though. It might be the 37. All right, number 11. We haven't done tangent in a while. Now, tangent of your angle is 63 over 16. So theta is the inverse tangent of 63 over 16. Once again, you can choose. It's an up to you kind of thing for these kinds of problems, and how people tend to freak out more often when you have a choice, going like, well, which one do I do? I mean, yes, you just do it. 75.74 is around 76 degrees. Okay. Yeah, that makes sense to be that, not obtuse, but that close to 90. And lastly, number 12. Again, I think this is a 3, 4, 5 triangle, but I think it's the lesser angle, so I think the answer is going to be 37. Let's go back to cosine. Cosine of an angle adjacent to 72. This hypotenuse here is 90. So theta is the inverse cosine of 72 over 90. Oh, that's 8/10. Yeah, that's that 0.8 again, so it's definitely going to be that. Oh, then does that mean it's the 53 degree angle? No, because it's the cosine, not the sine. So 72 over 90. This should be the 37. Yeah, 36.86. So 37 degrees on that guy. So repetitive. Oh, number 12. Sorry, repetitive for sure. Apologies. This I should manufacture this differently. Sorry that I didn't. But you know, you have so many other problems to do with. All right, guys, I have 4 word problems to do with y'all, so let's go ahead and take a look at those. A 25-foot ladder leans against a building. The ladder's base is 13.5 feet from the building. Find the angle which the ladder makes with the ground. So if you just came off the previous video, hopefully you know what I'm doing with these word problems. I have ground, and I have a building right here, and then I have a ladder. Ladder. So there's my ladder. It's a 25-foot ladder. The ladder is 25 feet right there. Here's the right angle of the ground with the building, and the ladder's base is 13.5 feet away from the building. That's this guy here, just that length. They say find the angle which the ladder makes with the ground, so I need to find out this theta right here. That's my setup. It's all about drawing it before you get it set up. So the cosine of your angle, and I'm doing adjacent over hypotenuse, which is why I choose cosine, 13.5 over 25. Theta is going to be the inverse cosine of that guy. Now, these are degrees. It's not, it's a word problem, but like any other angle measure, the answer is degrees. Word problem or not. So inverse cosine of 13, my answer is not in feet. It's an angle measure that I'm looking for. Just keep in mind, this is 57.3. I'll just say 57 degrees. We seem to have been doing angles to the nearest whole degree. Remember that when we do these things, they are in a vacuum, meaning you're doing inverse trig on all of these ones. But if I combined it with intermixed it with some other problems, make sure you know when to use trig versus inverse trig and what you're drawing. In order to reach the top of a hill, which is 250 feet high, one must travel 2,000 feet straight up a road which leads to the top. So this will look like, again, this kind of has to do with if you did the previous problem set with me. So kind of like I got my hill like that, one must travel right here 2,000 feet straight up a road, not literally straight up a road, but 2,000 feet up the road, which leads to the top. If you want to reach the top of the hill, that's 250 feet high. So this guy here is your 250. And this is where there's like an imaginary thing, or if there was a tunnel, but there's an imaginary dotted line here meeting to the road to really make the right triangle what it is. Find the number of degrees contained in the angle which the road makes with the horizontal. Here's the horizontal, and here's the road. Here's the angle. It's probably not very extreme, but it looks like sine will be used. I'll go quickly with this one here. Theta is going to be the inverse sine of opposite over hypotenuse, 250 over 2,000. 250 over 2,000 is 1/8. That doesn't matter for the answer, but if you did reduce it, that's what we would use. Inverse sine of 250 over 2,000. 7.18 degrees, around 7 degrees. I don't know if that's realistic or not as far as road things, but we saw one in the previous video, which was 12 degrees, which was pretty huge. I mean, if you consider this one here, right? Roads don't go this sharp, and when I drew this was like 36 degrees. That's very sharp. All right. A ladder leans against a building. The top, well, let me copy paste this first, just so I have something. Ladder leans against a building. The top of the ladder reaches a point on the building which is 18 feet above the ground. So the point above the ground, boom, is your 18 feet right there. The foot of the ladder is 7 feet from the building. Here's foot of the ladder, here's the building, there's 7 feet. Find the measure of the angle which the ladder makes with the level ground. So this time here, again, your theta, we want to use tangent this time. So the tangent of theta is 18 over 7, and theta equals the inverse tangent of 18 over 7. Now, I never hope that these word problems ever do have kind of unrealistic things, so thank goodness this ladder is going to be propped up a little more than 45 degrees, because if not, you'd probably be slipping out. Or it's a different kind of ladder and different kind of situation. Inverse tangent of 18 over 7, I'm getting about 69 degrees. All right. There we go. And lastly, number 4, a wheelchair ramp. It's 4.2 meters long. It rises 0.7 meters. What is the angle of inclination to the nearest degree? So the ramp is 4.2 meters long. So here's just like some ground level, right? This is you looking at the side, watching some guy wheel up the wheelchair ramp, right? Here's let's draw a wheelchair. How does Professor Xavier have a wheelchair? There's a weird wheelchair. It's speeding up the ramp. So the ramp is 4.2 meters long. Not the base from the foot of the ramp to the end of the platform and whatever. No, this part here. This is 4.2 meters long. And it rises 0.7 meters, which that's a couple feet. Rises a couple feet. Find what is the angle of inclination to the nearest degree. And yeah, see, not all these problems are like perfect. This isn't like, hey, you've accomplished every kind of trig problem that there can be. These have all been angles of elevation. They've always asked about this particular angle, but you know what? We're getting started with them pretty good. So the sine of our angle is 0.7 over 4.2, which, by the way, reduces to 1/6. So theta is the inverse sine of 0.7 over 4.2, which is our last answer. And I want to get it. 0.7 over 4.2. 9.59 is around 10 degrees. Whoa. Is that a steep wheelchair ramp? Probably. Work your muscles. All right, guys, that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. I wanted to make these ones super quick. If you want to find another problem, just go down to the description section below, and hopefully I have a timestamp for you. Thank you so much. Take care. I'll see you in the next one, whatever it may be.